Hello everyone. In today's video, I want to showcase how I do some basic analysis on cash secured puts using Python. More specifically, I'll use the yFinance Python package to retrieve stock option data and then calculate returns for cash secured puts. There are some prereqs to understand this content. First, we need to have high-level knowledge about cash secured puts. For example, what is a put option? What does it mean to sell a cash secured put? And also it's helpful to understand what's the distinction between in-the-money versus out-of-the-money options. And also we need some Python experience. For example, how do you pull options data from yFinance, and also how to interact with a Pandas data frame. Now, if you're not familiar with pulling data from yFinance, you can take a look at the previous video where I showcase how we can pull options data with yFinance. Alright, so let's first get the put options chain for a stock. So here I'm going to be using yFinance Python library. I've already installed the library, and here I'm importing it as yf. I first get a yFinance ticker. So yFinance ticker is the entry point for all pricing and metadata about a stock. So here I'm getting a yFinance ticker for NVIDIA. Then with the ticker I can get the put option chain. And you can see that by calling the option underscore chain function. And I'm specifying an expiration date of May 9th, and then also specifying that I want the put options. So the put option chain is returned in this puts df or puts data frame, and this is just a Pandas data frame. So you can see that this data frame has information about the put option chain. You can see various different strike prices, bid and ask prices, volume, and so on. Now, before we look at any code, it's helpful to understand or explain in plain English how we want to calculate the returns for the cash secured puts. So for simplicity, let's assume that we're selling one cash secured put contract and with no leverage. I'm pointing out no leverage because this will make the calculation simpler, and you can imagine like maybe you're trading the put options in a tax advantaged account. So there are four things we need to consider. First is the capital required. So this is how much capital you'll need to spend if the put option is assigned and you need to purchase the shares. So the capital required here is going to be the strike price times 100. And it's 100 because we're buying one contract, and one contract has 100 shares. The next thing is the collected premium. So the collected premium is going to be the option price times 100. So since we are selling put options, we're going to collect premium immediately when we sell the option. Next is the return as a percentage. So return is just going to be the collected premium divided by the total capital required. Now this return is only going to be for the period up to expiration. So for example, if we sold a cash secured put that expires in 1 month, then this return would only be for that month. However, it's more helpful to calculate the annualized return, because the annualized return helps you benchmark across other investments. So to calculate the annualized return, we're going to multiply the return times the number of days in a year divided by your days to expiration. Before we can calculate the returns, we need to take care of a few things. First, we need to calculate the DTE, or days to expiration. And this is important because we will use DTE to calculate the annualized returns. To get DTE, we will find the number of days between the current date and our expiration. So in this case, I'm looking at options expiring on May 9th, and at the time of recording, we have 15 days until the expiration date, and so my DTE is 15 days. We also need to calculate the current stock price, because this will be used to determine if an option is in the money or out of the money. And yFinance makes this very simple. We can use the ticker.info and then retrieve the current price attribute. So at the time of recording, the stock price is around $106. Alright, so now let's actually calculate the returns on out-of-the-money put options. So you can see here, I'm applying a filter condition to the puts data frame to retrieve the out-of-the-money puts. And for my filter condition, I'm specifying all options with a volume greater than 0 and also a strike price less than the current price times 1.1. So generally, out of the money put options will have a strike price less than the current price, but I'm adding an extra 10% buffer here because later on I want to visualize some of the in the money puts. But in practice, you would just do strike price less than current price. So once I apply the filter condition, I will have my out of the money puts in a data frame. And then next I can use different Pandas data frame transformations to calculate all of the financial metrics. So if you remember from the previous slide, we need 4 main things. We need the capital required, total premium, return, and annualized return. So to calculate the capital required, I'm just going to multiply our strike price times the total number of shares. In this case, the total number of shares is 100 because we're assuming that we will sell one contract and each contract has 100 shares. Next, we need to calculate the total premium, which will be the option price that we receive times the total number of shares. And for now, we're going to assume that we sell at the bid price. So the bid price will be the lowest end, but in practice, you might sell closer to the ask price or maybe at the halfway point between the bid and ask. But to be conservative, let's say we're going to sell at the bid price, and so our total premium will come from the bid price. Next, our return will be our total premium divided by our capital required. And then the annualized return will be our return times the number of days in a year divided by the DTE. And then finally at the end here, we are just performing some cleanup operations to the data frame. And this is a snapshot of the return data frame. There's a lot of information here, and later on I will present this in a chart format, which will be easier to understand. But you can see here that we've created these 4 new columns. We have capital required, total premium, return, and annualized return. And one general trend you can see here is that as the strike price increases, the annualized return also increases. So this is a natural thing you'll see across all put options. So now the next practical thing to think about is, can we beat benchmarks? So suppose we want to beat a benchmark of 10%. So we can apply a very simple Pandas data frame transformation to look for all options that will have an annualized return greater than 10%. And that's what we can see here. Now, instead of looking at tables, it'll be much easier if we can visualize all the return data. So we can leverage the Plotly Python library. This library makes it very easy to create charts and also to add some interaction to the charts. So here's some basic code to create a scatter plot. You don't need to worry too much about the details, but just focus on the high-level concepts. So first here at the beginning, we're going to create a scatter plot where on the x-axis will be the strike prices and on the y-axis will be the annualized return. Then we're going to add a horizontal line for our benchmark rate of return. So in this case, we're saying we want to beat a benchmark of 10%. And then also I'm going to add a vertical line at the current stock price. So this will help us distinguish between in the money and out of the money options. And this is the chart we get. So we have a scatter plot of NVIDIA annualized return versus strike price for put options. You can see this dashed red line indicates the required rate of return we want. And then this green dashed line is the current price. And so this helps us identify which of the put options are in the money versus out of the money. And every one of these purple dots represents a put option. And you can see as I hover over them, you can see the strike price, the annualized return, and then total premium also. So going back to the current price line here, since we're dealing with put options, then every point to the right of this green line is considered in the money option, and everything to the left is considered a out of the money option. So since we're dealing with cash secured puts, we want to focus on out of the money options. So basically we want to look at all the options to the left of this green line. And you can see the general relationship here that as the strike price gets closer and closer to the current stock price, or in other words, as the option gets closer to the money, that the annualized rate of return increases. On the other hand, as the strike price decreases and gets further out of the money, that the annualized rate of return decreases. And we can actually zoom in into the chart. Since we're dealing with Plotly, we can just specify an area we want to zoom into. And you can see here that eventually the option gets further out of the money, and the associated rate of return is going to get lower and lower, and then below our required rate of return at 10%. So what does this mean? For example, if you look at this option here, it has a strike price of $89, and the annualized rate of return is 10.66%. Whereas if we go one strike price below at $88, now the annualized rate of return is at 9.4%. So if we had a very strict required rate of return at 10%, then we would have to ignore this put option and all other put options below it. Now, just to be very clear, this type of analysis is very surface level, because here we're only looking at the rate of return versus strike price. If we want to make a more informed decision on whether to sell a given option, we need to look at things like the risk or the delta value of the option. And unfortunately, with the data source we're using, which is yFinance, it does not provide the Greek delta value. But hopefully we can use this as a foundation for future analysis. As I mentioned before, there are some limitations to the yFinance library, which limits some of the analysis we can do. So the two main limitations of yFinance are, number one, it does not have the Greek values such as delta or theta. And these Greek values are very important for analyzing options and understanding which option to buy or sell. So we would need to calculate these ourselves or find alternative data sources. The second limitation is that yFinance will have some data delays. So all the option pricing information we get will not be up to date. Finally, I want to summarize all of the things we've done so far. We have retrieved put options chain data with yFinance. Then we calculated the return and annualized return for out-of-the-money puts. Then we visualized those returns with Plotly. And now there are some limitations based on the data we've had, but we can imagine that future analysis can be significantly improved if we had Greek values and more up-to-date data. However, I believe this is the foundation for future options analysis.